All right, so let's get started. This is the next lecture, and we're going to go over the topics is the hyetograph, the hydrograph, the SCS curve runoff method. We're going to go over curve numbers in the TR55 program. We'll talk about pre and post development and agency jurisdictions. The homework is going to be posted on Blackboard. Quizzes 2's already uploaded, so just look for homework 2 and quiz on Blackboard or in the future Canvas. All right, so the hyetograph. The hyetograph, we want to start with understanding what frequency and return period is. Now, go ahead, I'm not going to read through all of this, but this gives you some information, and it will be in the PowerPoint that I posted. When we're talking about frequency and return period, we're talking about our design storm. It is the probability of when something or when a storm occurs and what frequency. So usually when somebody says you have a frequency or a return period, you're talking about a 10-year, 24-hour storm, a 100-year, 72-hour storm, something like that. The probability. Now when somebody talks about frequency or the return period, it's like a 100-year storm can actually happen back to back. It doesn't mean that it's going to happen every 100 years. Statistically speaking, that's what has occurred, but it could occur every day, like back-to-back hurricanes. Okay, so when we're talking about the hyetograph, now the hyetograph is just what we want to do is the representation of our excess rainfall. We talked about rainfall coming down, and we also talked about the abstractions, the evaporation, infiltration, and storage. So if you look at the graph, you've got your hyetograph here, and this is all the rain that's fallen, okay? Now, when it falls, this is in times, a quarter of an hour, a half hour, increments. So as it falls, you're using a rain gauge, and you're actually getting how much rain has fallen. Now, the intensity, notice that the rainfall varies. So this is inches per hour. So you go out and you take a rain gauge, and it's usually a tipping bucket or something like that, and you get how much rain falls during a certain amount or a certain period of time. And you plot it of time versus precipitation inches per hour. Now, when we're using the hyetograph, what we have to take a look at is the excess. That's what we're caring about when we do the runoff. Okay? So when we take a hyetograph, you can either take a look at it, I'm going to go back one, as in a graph that looks like this, and this is what we'll plot compared to our hydrograph. But sometimes we use a cumulative precipitation, where these are all of our times, but when we go back and we look at this graph, you can see that this is an increment, and then I'm going to add this much, and then add this much on top of it, and add that. So I'm actually adding each one of these values in a mass height, whoops, too far, basically a cumulative precipitation. So it goes all the way up to 3 inches. So all I did was basically add up these until time of 2 hour. Okay. Now these should start to look kind of familiar. We looked at the SCS curves, S curves of rainfall intensities when we started talking last lecture. Now, what I said at the beginning is in the blue or in the magenta color is the runoff. So the whole thing is the rainfall, okay? But then I have the abstractions, the bluish color. So the magenta color or the pinkish color is the amount of rain that I actually am having to work with in a hydrograph that's actually going to run off my watershed. Now, remember what I said, the mass cumulative or the cumulative precipitation? It looked like this curve. This goes up to 1. This is like a unit. So it is basically set as in a time of 24 hours and a fraction, which is like 100% of the rain, a 0.5%. And we talked about basically at 12 hours is when our peak is going to occur for a 24-hour storm. The information where these types of curves are coming is from this map, and it's the NRCS's rainfall distribution maps. Okay, so here in Florida, we're either a type 3 or a type 2, depending on what county we're in, where we're working at. So this is a mass hyetograph. Again, notice that the mass hyetograph goes, a time ratio is 1 on the bottom, and it goes for a rainfall ratio of 1. This is usually called dimensionless graphs, because we can assume one thing at the bottom and it'll allow us to calculate on top. Okay, so it is a ratio of inches to inches and hours to hours. Okay, so to create a mass hyetograph, over here on this side we have time, and it's got like 1 o'clock to 1:15. So that's 15 minutes. 1:15 to 1:30 is another 15 minutes. So these are in 15-minute increments. But the sum of times, it's a total of 90 minutes, right? So I keep adding up my 15s until I get to the 90 minutes. Now the precipitation is in inches. So that is how much it's rained in that first 15 minutes, in that second 15 minutes, in that third 15 minutes. Now the intensity is, see the 0.4? I'm going to take that and divide it by a quarter, 0.25, because 15 minutes is a quarter of an hour. Okay? And then I'm going to sum up my precipitation. So basically it's these just accumulated. And then I turn both of those into ratios. Now I've got a 1-to-1 for my hyetograph. Okay? Now the reason we use these is basically for developing hydrographs. All right, so now if you look at the top in the gray and the blue, that's the hyetograph flipped upside down on our timeline. Okay, that's what I'm looking at in this picture for right now. The gray part and the blue part added together is the total rainfall. Now you have this curve that comes through here. That's your evaporation, that's your any type of your abstractions, your infiltration to the ground, your depressional area. So what we care about is the blue. That's actually what's getting into our watershed and running off the soil. Okay? Now, over here it just says 1 inch of excess rain over 1 acre. So if this blue represented 1 inch of rainfall, and let's say I had a 1 acre watershed basin, then I could say that there's 0.083 acre feet of runoff, okay, that's coming onto our watershed. All I did was take the rain, the excess precipitation, and multiply it by the area of my watershed. Now, a lot of this with the hydrographs says, okay, it rains uniformly over the entire watershed. That's not true, but if it's small enough, it does rain uniformly over one place. Now, the second part, the reason I'm showing you these two calculations, in most of the agencies we're required to do acre feet in design, whether we're discharging out of a pond or not. And the computer gives us it in just feet or feet squared or feet cubed. So we have to know how to convert. Now, here's the other thing I want to show you on this graph. This graph was really kind of cool because it shows you all the different times when something occurs. What we care about is the ones that I've listed here in red. I and I1, or 1 and 1A, however you want to say that. And that's our time of concentration. The other ones I'll talk about it in a little bit. All right, so I've got a new clicker, so I'm going the wrong way today. All right, so I'm going to go to the next session and I'll talk about hydrographs. Basically, I'll talk about how we take the hyetograph and develop a hydrograph from it. All right.